My name is Mehdi Sabraoui. I'm a student at University of Louisville. This was my master's project. After presenting it, the professor threw out the idea of, hey, maybe you should go present this in front of a bunch of people who probably know more about the topic than you do and can call you on all your bullshit. I was like, yes, let's do it. That sounds great. So this is an overview of the presentation, just in case the description was ambiguous. I'm going to do a slight overview of the ICS environment, then an overview of the Sixnet Universal Protocol, some fun stuff to do with it, and finishing off with some defense. Let's get started. So I've created a set of tools that makes compromising a Sixnet device sitting on an Ethernet network really easy. I decided to do this as a proof of concept to show how poorly SCADA applications regard security. My tool is called Sixnet Tools. It's for poking at Sixnet things. It looks like this. And let's get at it. First, let's start with a little background. SCADA stands for Supervisory Control and Data Acquisition. So it's all these networks that comprise all the little gadgets and gizmos that control the industrial machinery. Think oil and gas pipelines, think water treatment, think chemical plants, think automotive plants. These are SCADA and DCS networks. In the day-to-day operation, they allow an engineer to monitor all the status of all the processes from the comfort of his own desk. And a network is a network. That's not really the focus of this talk, so let's move on. An HMI is a human-machine interface. This is the software that sits on the engineer's computer. It allows him to communicate. It provides a nice shiny GUI for him or her to interact with the machines, to control the valves, to monitor all the alerts and things like that. For Sixnet, this is called the Sixnet IO Toolkit. As you can see from here, it'll have a list of all your SCADA devices. It lets you manage the different configurations. If you want to load up new firmware, this will allow you to do it. Let's see. It's also, this toolkit is available for free on Sixnet's site, regardless of if you have any of their little gizmos. Here is one of the little gizmos. It's a remote terminal unit. This is what we have down at the lab at Louisville's ISRL. It interfaces directly with whatever machine you want it to. It has the important bits to notice here. It has a few digital I/O, it has a few analog I/O, it has a few UARTs and 2 Ethernet ports up the top. It has a lot of shiny blinking lights to attract bugs. And so it's running Sixnet's proprietary software on top of Linux 2.6. The proprietary software is kind of more of a rootkit, but we'll get into that later. This is the type of device that I wanted to focus on. It's no secret that SCADA security is kind of a dumpster fire, so I wanted to show how, and this is the perfect device to do it on. So to that end, I decided to shoot a bunch of electricity at it to see how it all bounced off. This involved Wireshark, and a lot of Wireshark. So I started capturing packets. Tons and tons of packets. Oh my goodness, it was so frustrating. All the packets. Some of the things that came out of this you might notice is that when using Ethernet, all of Sixnet's communication occurs over UDP on port 1594. Actually, Wireshark recognized this as Sixnet. And 11 billion packets later, after some trial and error, plenty of frustration, got a prototype driver for Sixnet's Universal Protocol. Using Python, by the way. You couldn't tell. Let's go back. This is, I don't know if you guys can see it back there. Down here, that series of hexadecimal characters, that is what a Sixnet packet looks like. It's all embedded in the data field of the UDP packet. So I was tearing my hair out trying to figure out what all those numbers mean. Let's see. So what is the Sixnet Universal Protocol? It is a proprietary communication protocol that all of Sixnet devices use. I had some help with some fields. I found a document about the Sixnet Universal Protocol, not on Sixnet's site, on a University of Hawaii, I think, just server that they probably forgot about years ago. So it was about 15 years old, this document. And it was for serial, not Ethernet, so I had to pick and choose what I could get out of that. So I kind of had an idea of these fields that I was looking for. If you're at all familiar with Modbus, this is very similar to Modbus, the exception of the command right there. Modbus just has read and write coils and things related to SCADA. Sixnet has commands that you can be a lot more devious with. You'll see. You probably already know, but you'll see. So the lead and length. Length is length of the packet. The lead is the whether it's hex or ASCII or anything like that. I'm not sure why it has the source and the session, destination, and the sequence, because that's all handled by UDP. Then the command and the data, and then of course the CRC. Let's move on. So I started off with I/O just to see what I can mess with. This is what the protocol is intended to do, after all, is read and write the coils on the device. So this set digital, all it does is set the digital outputs, and on the device itself it makes the little lights blink, which is cool. So I sat for a few hours and watched the lights blink, which is what I like to do. It helped me get a feel for the Universal Protocol. It also helped me get a feel for Python. This is the first time I'd ever used Python was for this project. Python's really cool. Let's see. So moving beyond what it's supposed to do and more into the undocumented function codes, to create artificial tiers of licenses for its software, Sixnet, the software that's running on the device, it intercepts traffic going on the FTP and Telnet ports. Depending on the level of license you have, will let the packets through to the actual services. Nmap will say that these ports are open, but you can send as many packets as you want at them. You can scream at them all you want. They won't reply. But we had found out that there's a way around this, so we kept on digging. I found that you can access the underlying file system from the HMI using Sixnet's Universal Protocol, which is a totally valid feature. It makes sense. I mean, this is running on Linux 2.6 after all. So after poking around a little bit, I found a general config file. It's right here. This is in the file system of the device itself. Opening up that general config, you'll see enable FTP equals 0, enable telnet equals 1. So setting both of those to 1, and suddenly those services are active. If this is the amount of effort that Sixnet goes and puts into protecting its own money and licenses, you can kind of see where this presentation is going. So setting those to 1 makes it all work. Let's see. So running that process through Wireshark, we can get some more of these undocumented function codes. For example, you can see here that file path right there, etc/sta config/general.config. That's the one I pointed out before. So that's going across the wire. So here's how these commands work. These are the file manipulation commands. The data in the command field is 1A, so that's the command for file manipulation. And then the data for reading is different from writing, and those are all there. They'll be on the presentation. They'll be on the video if you really want to dig into them. Also, you can just have my code. I mean, it's fine. But so for reading, you want to send 1A followed by these bytes followed by the file path, and for writing, you want the size of the file that you're going to write followed by where you want to write it, and then both read and write end with a null terminator. So the RT responds with acknowledge, just like it would in Modbus, and some weird 5-byte code, which is probably the file descriptor. And then to continue on the reading and writing, it's 1A again, but a different following bytes. 06 this time for read, followed by the file descriptor. And then for write, it's the file descriptor, then the byte at where it's going to start in the file, start writing the file, and then the length that you're going to write and the data that's actually going to be put into that file. Oops, wrong direction. Okay. And then it comes back with the file descriptor for read, the start of the file, where it's starting and reading the file, and the length it's reading and the data. It's important to note that just like Modbus, Sixnet will never send 2 packets in a row it'll never send 2 packets in a row. It's always call and response. So if I want more of the file, I have to send another read command, this time with the start length, the offset into the file that I want to read, and it'll bring back the next 250 some bytes. And you just repeat the process until the whole file is read or the whole file is written. So, more electrons. Let's see what else we can do with this. Playing around more with the toolkit, more with Wireshark, and suddenly this comes up. I don't know if you guys can read that back there. cat etc/sixnetinfo. That kind of looks like a shell command. So let's see what we can do with that. here we have shell commands. Turns out you can send whatever scripting command you want to over the Sixnet Universal Protocol, and it'll just run it as though you're on the system itself. So here is the structure for a data command, a shell command. Command is D0, and then those first 3 bytes, honestly, I have no idea what they mean. But after that, you put in the command that you want to run, followed by a null terminator. From what I can tell, it only returns the first 245 characters of the output of that command. So it's not directly a shell. It's kind of a pseudo shell. Messing around a little bit later, messing around in a while loop later, and suddenly I have a very dumb pseudo shell to call my very own. And that prompt, by the way, root $, my shell code will actually send off who am I to the device and use that for this prompt. So this is a root shell on that device doing whatever the hell you want it to do. So since we have root, the next logical step would be to fork bomb it. So we create a packet that kind of looks like that. The important code is expanded. Here's the response. It says, okay. And then everyone dies. The pipeline explodes. The operator has to drive all the way out to the little substation and manually reset it. So that's the fork bomb. It's all destroyed and everything. Anyone have any questions? Wait, hold on. Let me get you started. Hey, Mehdi, how do you defend against this? What a good-looking question. So after messing around, after developing the tools, after finding these undocumented function codes, we submitted it to ICS cert because we're in this for good, after all. They sent it off to Sixnet to verify. ICS cert gave it a CVE with a bunch of scary numbers you can probably see up there. Sixnet's response was that we weren't using the latest version firmware. We pulled the firmware right off their site right before we started doing anything, so to us it was the latest. Apparently there's a new firmware that hasn't been released widely that completely solves all of this nonsense. It had been created for a specific client. It's due to release before the end of the year. It adds everything that this is missing, which is the authentication authorization. So let's see. So firmware 4.8. Actions such as read coils, write coils, actions such as read and write to the file system, actions such as any administrative access to shell commands or whatever, they can all be limited on a per user basis. And does it work? Well, it works well enough to lock a grad student who isn't careful out of the device and require full firmware reset, so that was my mistake, and about 6 hours of downtime in the lab. So yes, it works. The only problem is you go to Sixnet's website, pull up the latest firmware, it still says 4.3, which is the completely vulnerable firmware. This is the firmware that's running on all the devices all over the US, all over Europe, all over Asia. And you'll notice there's no indication there that there are gaping security holes in this firmware, even though literally at this instant it is being spoken about at DerbyCon. The ICS networks, the firmware upgrades on those networks happen somewhere between rarely and never. So it's a pretty good chance that these opcodes will be exploitable for the foreseeable future. All right, so for real this time, are there any questions? By manipulating the file system. That information is in. There are a few other built-in tools in the tool set to figure that out. It'll give you the firmware version of the device. You can pump out the ladder logic of it too. And so far, I've only been able to test it on this one specific RTU, but it is a universal protocol, and so it'll run on any device that supports that protocol. Anything else? Well, thank you guys very much. I finished a whole lot faster than I thought I would.